Alright, in this assignment, we are going to evaluate logarithmic expressions such as these. That means we're going to find a numerical value, a single number representing these expressions. But we are not going to use a scientific calculator like the TI-30XS Multiview. Not really. Instead, we are given these three facts, and we're going to use those in conjunction with these properties of logarithms. Now, having said that, we will actually use this calculator every now and then, but we are going to pretend that it is a four-function calculator. So we will just add, subtract, multiply, and divide, and that's it. Nothing else. Okay, what's up? So, sort of hold this in your mind. These are the numbers that we have to work with. We have 5 and 8 and 7 and 10. Okay, and really, okay, like these right here, they're all log base 5. So really, I shouldn't even be mentioning the 5 because that's automatic. Alright, think of 8 and 7 and 10. So we want to, wherever possible, rewrite these problems using an 8, a 7, or a 10. Now we will also be using an exponent table, so that's okay. 343. Let's look on the exponent table and see where we can find it. Alright, I see 343 right here. That is 7 to the third power. Alright, 7 is one of the numbers that we want, so this is sounding good. So I could rewrite this as log base 5 of 7 to the third power. Now, using our exponent rule, we can take any exponent and put it in the front like this. So this 3 can jump to the front and become 3 log base 5 of 7. Now, log base 5 of 7, we're given that fact. So this is going to be 3 times 1.21. So here's where I'm going to pretend that this is a four-function calculator and do 3 times 1.21. Well, I guess we didn't really need a calculator for that after all. 3.63 though. So that's going to be 3.63. I'm saying we didn't need a calculator because I can just multiply each one of these numbers by 3, and that's the same thing. Anyway, that would be the final answer to number 1. Now I'm going to zoom in on number 16. But remember, we want 8, 7, or 10. Last problem we used the 7. We didn't wind up using the 8 or the 10, so you don't have to use them all. Okay, so I'm seeing 80 and I'm seeing 7. Alright, I think I know where we're going with this, but I'm going to zoom in. Alright, as soon as I see this fraction, I'm thinking about the quotient property. Alright, log of A over C is the same thing as log A minus log C. So I could do that right now. So this would be the same thing as log base 5 of 80 minus log base 5 of 7. Now log base 5 of 7, there's the 7, ding ding ding. We've got it. Now 80. We want 8 or 10, but instead we have 80. Is there any way I could break up 80 so that I have an 8 and a 10? Well, of course. Alright, 80 is 8 times 10. So I can now use the product rule. Log of A times C can be broken apart as log A plus log C. So log of 8 times 10 can be split apart as log of 8 plus log of 10. And I still have minus log 7. All right, now I know all of these facts. I might as well write down this one that's right in front of my face. 1.21, so I have minus 1.21. What I got over here? Log 8 is 1.29. So this is 1.29. And then over here, log base 5 of 10 is 1.43. So plus 1.43. All right, so I'm just going to put this into my 4-function calculator. Well, I'm going to pretend. Okay. In fact, maybe I'll just do this off camera because you know how to add. So 1.29 plus 1.43. You don't have to see me type that in. You get it because you're super smart. All right, so add those up, you get 2.72. And then minus 1.21. So now I'm just going to subtract these. So minus 1.21, and I get 1.51 for the answer. You know, I'm just realizing I'm supposed to write these on the lines over there. Whatever, I can do that later. Alright, but that's it. That's the answer number 16. Okay, we have one more of these. So, log base 5 of 700. Now, using the product property, I could split this apart. 700, of course, is 7 times 100. Okay, so I could use the product property to write this as a sum. So this would be log base 5 of 7 plus log base 5 of 100. Now, there are 3 numbers I'm allowed to have: 10, 7, and 8. And that's it. Right now I have the 7, so that's good. But I have this 100, that's not one of the 3. But I can rewrite 100 using the 10. So I have a choice. I could either write this as log base 5 of 10 times 10. And then I could split this up as log base 5 of 10 plus another log base 5 of 10. Okay, using the product property. Or perhaps a simpler way to do it is to remember that 100 is 10 squared. You know, 10 times 10. So I could write it as 10 squared instead. So now I would use the quotient rule, which says if I have an exponent in there, I can put it in the front. Alright, so I just like this method slightly better. But you should get the same answer either way. So this would be the same thing as 2 times log base 5 of 10. So now I've got it down to just the logs that we know. So log base 5 of 10 is 1.43. So this will be 2 times 1.43. And log base 5 of 7 is 1.21. Okay, so I wish I had my trusty TI-30XS multi-view, because if I did, I could just type this whole thing in. But I don't, so I'm going to do it in 2 steps. Well, you know, I do, but I'm pretending that this is a 4-function bootleg calculator. So I'm going to go ahead and do 2 times 1.43 first. So 2 times 1.43 is 2.86. I knew that. So 2.86. And now we're going to add these together. And then that is going to be my final answer. So that's going to be 4.07. And that is how it is done. So that's the final answer for number 17. And that's going to do it for this video. Alright, I hope it was helpful. On the next video, we're going to solve log equations such as these. Pretty fun.